Hello students, welcome back. Previously we did some elementary problems like these. I don't have a lot of comments there, they are too elementary. Now I'd like to focus upon these two problems. Let me copy and paste these things. Okay, and then let's see, maybe some bigger font because we have some fractions here. Okay, all right. Now in these kind of problems, I see sometimes this kind of answer. Let's see, where are those? Yeah, this. Let me copy and paste. Especially this one. Finding the antiderivative of the numerator and finding the antiderivative of the denominator and then putting those into quotient, but that's not going to work. I have to find a way to reduce it. But then again, there's no such thing as quotient rule for antidifferentiation or integration. So what I do? Here's my suggestion. You can separate the numerator. Actually, before starting, let's put power form first. And then let's do this. Okay. Oop. Just a moment. Okay, all right. Oh, no. There you go. Okay, how do you like your first step? I can separate the numerator because denominator stays as 3x, x squared plus 2x minus 3x to the 1/2 power, x squared plus 2x minus 3x to the 1/2 power. I can separate the numerator. Make sense? And then, please note that I have just one term downstairs, so I can simplify them all. I should have just copied and pasted. X squared divided by x, so I just have x. Number part is 1/3. 2/3 x cancel out. Now number part 3 cancel out. 1/2 power, and down here the first power. So overall x to the negative 1/2 power. We successfully simplified, and each is a power function. And then we can use the power rule. 1/3 was there before. Add 1 to the power and divide. 2/3, and then this is just constant, so put x. And then this one, add 1 to the power and then divide. You can stop here, or if you prefer to simplify just a little bit, go ahead and do that. 1/3 times 1/2, so 1/6. And this one, reciprocal is just 2/1, but just 2. I guess that completes the problem. Let's see, is that what I have here? Yes, that's right. Can you do the same thing here for this problem? Stop the playback and try. Here again, let's consolidate all this into single power form. Oh, okay. I guess that's too much skipped step. And then put this into x to the what power? 3/2 power. And then go ahead with standard separation. Minus 4x to the 3/2 power over 2x squared. 5x to the, no, not just 5x and 2x to the second power. Let's put some space in between. So, are you happy with the separation? Some power form conversion is going to be helpful because radical is difficult to deal with. So that's usually my step 1. And consolidate this x and square root of x into 3/2 power. And most students will be able to do this in a single step. And then separate all those and okay, all right. Let's see. 2 cancel out, x to the 3rd power, 2nd power, we have just x. And the number part here, 4 divided by 2, so we have just 2. And x to the what power? 3/2 power, 1.5 power, 2nd power down here, so I have negative 1/2 power total. And 5/2, 1st power, 2nd power, so x to the negative 1st power. Okay, the separation is complete. Let's find out the antiderivative. Again, make sure that you take the antiderivative all at the same time, a single line. Keep the integral sign and dx until that moment because you did not apply any of the antiderivative formula yet. So antiderivative of x, 1/2 x squared, 2, and then apply the power rule, x, add 1 to the power, 1/2, and then reciprocal. Add 1 and divide. 5x, x to the add 1, 0, and then divide by 0. Oh, I can't do that. So power rule is not the way to go. This is going to be log of x. That's going to be it. You can leave it like that, but maybe a little bit of simplification here will help. I guess that's it. So how do you handle this? Separate the numerator, and then you get a bunch of power functions, and then you can apply power rules one at a time. For differentiation, we have such a nice thing called the quotient rule. Yes, I did it right. But there's no such thing for anti-differentiation. So you have to do it hard way like this. No other way. Okay, so much for elementary integration. That'll require just elementary techniques. Now let's consider problems that will require this expanded form, where we have to do this with 1 over a. That's something we are going to do in the next video.